January 2025. A Chinese startup nobody had heard of 3 months ago releases an artificial intelligence model that changes everything. Not because it's smarter than OpenAI's ChatGPT, not because it has more features than Google's Gemini, but because of what it costs. DeepSeek R1 matches the performance of OpenAI's most advanced reasoning model, ChatGPT-o1, on mathematics, coding, and logic benchmarks. The AI research community downloads it, tests it skeptically, and realizes it's legitimate. Then they see the price tag. OpenAI spent over $100 million training GPT-4. Meta poured billions into Llama 3. Anthropic raised $16 billion to build Claude. DeepSeek claims it trained R1 for $6 million using just 2,000 Nvidia chips, 1/10 the compute resources Meta used for Llama 3. Within 72 hours, DeepSeek becomes the #1 downloaded app in the United States App Store, overtaking ChatGPT. And then the markets wake up. January 27, 2025. Wall Street opens to chaos. Nvidia, the chip company that became the face of the AI revolution, loses $600 billion in market value in a single trading day. It's the largest one-day loss for any company in recorded financial history. AI stocks across the board collapse. Bitcoin drops 6.5%. Crypto AI tokens crater 50% or more. Investors panic with one question. If a Chinese startup can build competitive AI for $6 million instead of $100 million, what does that mean for every assumption about compute costs, chip demand, and the billion-dollar infrastructure bets that define 2023 and 2024? President Trump calls it America's Sputnik moment and demands an immediate government response. Silicon Valley scrambles to explain how this happened. But here's what nobody predicted. The very restrictions designed to destroy China's AI ambitions, the export controls that banned Nvidia from selling its most powerful chips to Chinese companies, created the exact conditions for this breakthrough. DeepSeek couldn't buy H100 chips, Nvidia's flagship AI processor. They were stuck with H20 chips, a deliberately weakened export version running at half the speed. American policymakers assumed this would cripple Chinese AI development. Instead, it forced Chinese engineers to stop chasing raw compute power and start optimizing every line of code. While Silicon Valley companies threw money at the problem, buying tens of thousands of H100s and building billion-dollar data centers, DeepSeek's team worked under constraint. They couldn't outspend their competitors, so they had to outsmart them. The technical approach wasn't magic. It was a combination of strategies the AI research community had been discussing for years, but rarely implemented at scale. DeepSeek used a mixture of experts architecture, which activates only relevant parts of the neural network for each query instead of running the entire model every time. They deployed sparse attention mechanisms that reduce computational overhead without sacrificing accuracy. Most importantly, they focused on test time scaling, improving the model's performance during inference when it's actually answering questions rather than pouring infinite resources into pre-training. These techniques were known. What was unknown was whether anyone could make them work at frontier model quality with a fraction of the budget. DeepSeek proved it was possible. The company itself emerged from an unlikely origin. Its founder, Liang Wenfeng, wasn't a typical Silicon Valley entrepreneur. He was a quantitative hedge fund manager running High Flyer, a Chinese investment firm that used algorithmic trading strategies. In 2023, Liang decided his firm needed better AI tools for financial modeling and couldn't find what he wanted on the market. So he started DeepSeek as an internal research project. Unlike Western AI labs obsessed with raising billions in venture capital, DeepSeek stayed lean, funded by Liang's hedge fund profits. They had no pressure to deliver immediate commercial products, no board demanding monetization, no valuations to justify. They could focus purely on research efficiency, and they did. By December 2024, DeepSeek released V3, a model competitive with GPT-4 Turbo. The AI community noticed, but didn't panic yet. Competitive models weren't unusual. China had produced strong AI research before, but when DeepSeek published their training methodology and cost breakdown, skepticism turned to alarm. $6 million. The number seemed impossible. Researchers at OpenAI, Google, and Anthropic started reverse engineering the approach, trying to understand what they'd missed. Some claimed DeepSeek was lying about costs, hiding subsidies or compute time. Others ran independent tests and confirmed the results were real. The model worked. The efficiency gains were legitimate. And if DeepSeek could do this, what did that mean for companies that had spent billions assuming compute was the only moat? Then came R1 in January 2025. This wasn't just another language model. It was a reasoning model designed to compete directly with OpenAI's O1, the crown jewel of their product line. ChatGPT O1 had been positioned as the future of AI, models that could think step by step through complex problems, chain reasoning across multiple domains, and arrive at solutions human experts would struggle with. It was OpenAI's answer to the scaling plateau, the growing concern that simply making models bigger wasn't producing proportional intelligence gains anymore. R1 matched O1's performance on the AIM mathematics benchmark, a test used to identify gifted high school students. It performed comparably on coding challenges and logical reasoning tasks. And DeepSeek didn't just release it, they open-sourced it under an MIT license. Anyone could download the model, inspect the code, and build on top of it, for free. Now let's address the counter-argument. Critics immediately pointed out that DeepSeek's $6 million claim only covered training costs, not the salaries of researchers, infrastructure overhead, and prior failed experiments. Fair point, but even if the true cost was 10 times higher, $60 million, it's still a fraction of what American labs spent, and the broader implication remained. Algorithmic efficiency could substitute for raw compute power far more than Silicon Valley had admitted. For years, the narrative had been that AI leadership required infinite capital, that only the richest companies could compete, that startups were doomed because they couldn't afford enough GPUs. DeepSeek shattered that story. They proved that constraint breeds innovation, that scarcity forces creativity, and that throwing money at a problem isn't always the optimal solution. The market reaction on January 27th reflected this existential crisis. Nvidia stock didn't just drop because DeepSeek threatened chip demand, though that was part of it. It dropped because the entire AI investment thesis was suddenly in question. If models could be trained for millions instead of billions, did tech giants need to spend hundreds of billions on data centers? If efficiency mattered more than scale, were the massive capital expenditure plans announced by Microsoft, Google, and Amazon justified? And if a lean Chinese startup could outmaneuver the best-funded labs in the world, what was the actual competitive moat for American AI companies? These questions had no good answers. So investors sold. The geopolitical dimension added another layer of irony. The Biden administration's 2022 export controls on advanced chips to China were explicitly designed to prevent Chinese companies from building cutting-edge AI. The logic was simple. Deny them access to Nvidia's H100 chips, and they'd fall years behind in the AI race. The policy was hailed as a strategic masterstroke, but it ignored one crucial variable: engineering ingenuity under pressure. When you tell the world's largest manufacturing economy and its top engineering talent that they can't have the best tools, they don't give up. They figure out how to build better tools. Or in DeepSeek's case, how to build the same results with inferior tools. The export controls didn't slow China down. They forced Chinese companies to abandon the more compute solves everything mentality and pursue efficiency. And efficiency, it turned out, was the actual frontier. By late January, the political fallout intensified. The U.S. Navy banned DeepSeek from all government devices. NASA followed. Texas prohibited state employees from using it. Taiwan banned it entirely on January 27th, the same day markets crashed. The stated reason was national security. DeepSeek was subject to Chinese government censorship and data collection laws. This wasn't unfounded. Researchers quickly discovered that DeepSeek's models refused to answer questions about Tiananmen Square, Taiwan's political status, or anything critical of Xi Jinping. When asked about sensitive topics, the model gave boilerplate responses aligned with Chinese Communist Party positions. A cyber attack shortly after R1's release exposed over 1 million user records and revealed jailbreak exploits that allowed users to bypass some censorship filters, but the underlying alignment remained. DeepSeek was, undeniably, a tool built within Chinese political system. But here's the deeper question. If DeepSeek's censorship disqualifies it from Western use, what about the efficiency breakthroughs the model represents? Should American labs ignore the techniques DeepSeek pioneered just because the company operates under Beijing's oversight? Of course not. Within days, AI researchers worldwide were dissecting DeepSeek's open-source code, extracting the efficiency methods, and integrating them into Western models. The knowledge was out. The genie couldn't be put back in the bottle. DeepSeek had done something unprecedented. It had made cutting-edge AI techniques freely available to the entire world, forcing every other lab to adapt or fall behind. The timing couldn't have been worse for American AI companies. Just weeks before DeepSeek's release, OpenAI, SoftBank, and Oracle had announced Stargate, a $500 billion infrastructure project to build AI data centers across the United States. The announcement was positioned as a declaration of American AI dominance, proof that the U.S. would outspend and outbuild any competitor. But after January 27th, the Stargate project looked less like visionary ambition and more like a monument to waste. If DeepSeek's approach was correct, if efficiency mattered more than scale, then building $500 billion worth of compute infrastructure was strategic malpractice. Critics started calling Stargate the world's most expensive museum before a single data center was finished. Jensen Huang, Nvidia's CEO, tried to calm markets by invoking Jevons paradox, the economic principle that when a resource becomes more efficient, demand for it actually increases rather than decreases. His argument, DeepSeek's cheaper AI wouldn't reduce chip sales. It would democratize AI, making it accessible to millions of new developers and companies who couldn't afford $100 million training runs before. That increased accessibility would create massive new demand for GPUs, not destroy it. Nvidia's long-term outlook, Huang insisted, was stronger than ever. Some analysts agreed. Others pointed out that Jevons paradox assumes sustained growth, not sudden obsolescence. If the next wave of AI models could train on consumer-grade hardware instead of specialized data centers, Nvidia's dominance was existentially threatened. And here's the final irony. China didn't intend to create DeepSeek's breakthrough. The Chinese government didn't mastermind an efficiency revolution. They didn't plan to undermine Silicon Valley's business model. They just wanted to build competitive AI under the constraints imposed by American sanctions. But those constraints, the very restrictions meant to kneecap Chinese AI, produced an innovation that American companies, flush with unlimited capital, never pursued because they never had to. Silicon Valley optimized for abundance. DeepSeek optimized for scarcity. And scarcity won. The days following Black Monday revealed just how unprepared Silicon Valley was for this moment. Internal emails leaked from major AI labs showed executives scrambling to understand what they'd missed. One Google researcher reportedly told colleagues that DeepSeek's approach should have been obvious, but that the company's internal culture of unlimited budgets had made efficiency research seem unglamorous. Why optimize when you could just buy more GPUs? The tech giants had been so focused on winning the arms race that they'd forgotten someone might change the rules of warfare. The impact rippled beyond just the major players. Hundreds of AI startups that had raised funding based on promises of enterprise-grade models suddenly faced existential questions from their investors. If DeepSeek could deliver comparable quality for a fraction of the cost, why would anyone pay premium prices for proprietary models? The venture capital community, which had poured $200 billion into AI companies just in 2024 alone, began demanding explanations. The AI boom that seemed unstoppable just weeks earlier now looked dangerously overvalued. What made DeepSeek's achievement particularly striking was the context in which it happened. This wasn't the story of a well-funded startup with celebrity founders and hype cycles. Liang Wenfeng gave almost no interviews. The company had no glossy marketing campaigns, no carefully staged product launches, no billionaires' backers promising to change the world. They just published research papers, released models, and let the work speak for itself. In an industry dominated by personality cults and reality distortion fields, DeepSeek's quiet competence felt almost anachronistic. But perhaps the most uncomfortable lesson from DeepSeek's rise is what it reveals about American innovation culture. For decades, the United States prided itself as being the place where constraints were overcome through ambition and resources. Silicon Valley's mythology celebrated founders who thought bigger, moved faster, and spent more than anyone else. But that culture optimized for abundance, not scarcity. It produced incredible innovations when capital was cheap and compute was plentiful. What it didn't produce was the discipline to do more with less. That discipline required different conditions that American companies, swimming in venture capital and cheap cloud computing, never experienced. until a Chinese hedge fund operating under export restrictions and modest budgets demonstrated what constrained innovation actually looked like. The story of DeepSeek isn't just about one company or one model. It's about the limits of the bigger is better philosophy that defined AI development from 2020 to 2024. It's about what happens when resource constraints force genuine innovation instead of incremental scaling. It's about how geopolitical competition produces unexpected outcomes, and how the tools designed to maintain dominance can backfire when they ignore human ingenuity. Most importantly, it's about the fragility of narratives. For 3 years, the AI industry sold the world on one story: that artificial intelligence required infinite compute, infinite capital, and infinite ambition, that only the biggest companies with the deepest pockets could compete, that AI leadership was a function of spending, not intelligence. On January 20th, 2025, a Chinese startup that spent $6 million proved that story was wrong. And on January 27th, 2025, the market punished everyone who believed it. The question now is whether Silicon Valley will learn the lesson or just wait for the next narrative to justify the next spending spree.